So let's fit a whole bunch of different families to these 2 points. In the last video, you learned how to fit quadratics to a bunch of things. Let's try and do some other ones, like a square root function, maybe an exponential function, maybe a logarithmic function. And the takeaway point here is it's really going to be the same process for all of them. It's like you choose the family that you want, and then you imagine what transformations, what kinds of transformations might you need, and then you plug in the values to solve for the particular values that you want for your transformations. So let's say I wanted to fit a square root function. I know square root function, without transforming it, starts at 0, 0 and kind of goes up this way. So let's think, what transformations could I apply that might send it through those 2 points? Well, it seems like no matter what, I'm going to need a vertical shift, because even if I scale it vertically, a point at 0 is not going to change when you scale it vertically, because 0 times any scaling factor is still 0. So let's add a vertical shift on the outside that I'll call C. So now I could imagine shifting it up, and it looks something like this. But maybe without any type of scaling, I'm going to miss the other point. So I could choose to have a horizontal scaling factor or a vertical scaling factor, and it kind of doesn't matter which we choose. So I'll put a vertical scaling factor on the outside. And so what we want to do now is we want to plug in the values we know to try and solve for these 2 constants that we don't know. So we don't really need to solve for C. There's no mystery about that. That's just equal to 3, so we can just write that in right away. And then we can solve for K by plugging in the other point. So I've got 25 for my Y value, root 5, because X is 5, and then I got 3 here, and so that gives me that K is what? It's going to be 25 minus 3, which is 22 divided by root 5. So I can write my final equation as 22 over root 5 times root x plus c. All right, so far so good. Let's try it with a different family. Let's say we want an exponential function. So let's not choose the base either. We'll say a to the x, and so a is one of the things that we're going to solve for. So I know that no matter what the base is, the y-intercept is always equal to 1, because anything to the 0 power is 1. So I know I'll need a vertical scale factor. And then depending on what a is, I think that that's going to give my curve enough flexibility, enough freedom, that we can make it go through this point. But let's plug it in and see. So we've got the points 3 and 0, and the points 5 and 25. Oops. So what can we do to solve this system? If you're you could always isolate and then substitute. That will work. If you're like me, you like elimination rather than substitution. And typically, for eliminating, I was subtracting one equation from the other. In this case, you could divide one equation by the other so that the k divides with the k. So let's say I'm going to do that. I'll have 3 over 25, k divides k to be 1, and then I've got a to the 0 divided by a to the 5. So a to the 0 we know is just 1. So this is now 1 over a to the 5th. And now I can solve for a to the 5th. So let's multiply both sides by a to the 5th. 3 over 25 equals 1. And now let's multiply by 25 and divide by 3. So that gives us 25 over 3. And now I can take the 5th root of both sides to solve for a. So a could be the 5th root of 25 over 3. And we actually already know from this equation up here, because a to the 0 is just 1, we also know that k is equal to 3. So putting those together, I've got y equals 3 times the 5th root of 25 thirds, but then that is to the power of x. You might wonder, could we just do this if we choose the base? So could we fit an exponential curve that's 2 to the x? Well, again, let's think of the transformations we might need to apply. So it seems like we need to apply a vertical scaling factor to take the y-intercept at 1 and scale it up to 3. The problem is it's not really clear how we're going to get enough freedom to go through both of these. You might think we could vertically scale it and then afterwards horizontally scale it to get over here. So you could have another factor like b over here. And that could be one approach. Another approach could be have a vertical scale factor k and then have a vertical shift c. So either of those are valid ideas. And for both of these, you could do the same process. You'd plug in what you know and solve for the constants that you don't.